Yeah. Before introducing our next speaker, please update the participants about the assessment which will take place tomorrow,
Sure, sir.
and
Hmm.
what are the pros and cons for
Of
proceeding
course.
towards the certification. Yeah.
Yeah. Okay. Hello, respected participants, dignitaries, guest members, and my beloved co-teachers. Wish you a very good afternoon and welcome to our Amity University Annual Faculty Development Program 2025, Day 4, Session 2. Hi, this is Swapnil, Assistant Professor from Fashion Design Department and your FDP 25 Coordinator and host. Just to remind you about our formalities and to all the participants, to successfully complete your participation and to avail the certificate, completion certificate of FDP, 100% attendance is mandatory with your feedback and assessment that would be shared after tomorrow's last session. So kindly fill your feedback and give us your suggestion. Okay. So I'm welcoming our next guest lecturer, eminent guest lecturer. As we already shared our schedule, this session, I'm honored to welcome our eminent lecturer, Mr. Virag Desai, a pioneer who actively contributes to the development of India's contemporary art form. Although Virag worked with various media, his journey as an artist has become exceptional with his huge three-dimensional works experimenting with unconventional media. While initially taking an expressionistic approach towards traditional art forms such as Tibetan thangkas and pata painting of rural Bengal, his work blend lines between abstraction and representation, space and surface. His creation express with the idea of consciousness, sexuality, and decadence. To talk about his few work, uh, Desai's current practice lies in the space between physical, temporal through procedural design, via sculpting, and 3D printing. Recently displayed at Art Exposure and India Story, Kolkata 2022, and India Art Fair, Delhi in 2023. He was the first ever Indian recipient for the Julius Baer Next Generation Art Prize in 2023 for his work with art and technology. He's participating in a collaboration with MG Select Cars. He veers towards the technical in his new media art, drawing inspiration from simulations, organic abstraction, and figuration, and emerging online cultures. So, today, he will enlighten us with his journey of experience and deep insight about 3D modeling and fabrication for art and design. Welcome you, sir. Grace us with your presence. Over to you.
Thank you. Am I audible?
Yes, sir, you are perfectly audible.
Great, great. Yeah, thank you for the introduction. I am Virag Desai, and this is my colleague Vedant Singhania,
Hello, sir.
and we often collaborate. So let me introduce myself first. So yeah, I graduated in 2011 with a BFA in design and painting from the Art Institute in Chicago. Over there, I did a few things of a very small department, like emerging department called Art and Technology. So I kind of had a propensity to work within that space. And over time, I've been working as a designer. I've been working on as a production designer for film, for plays, all sorts of things. But then during COVID, I started getting very interested in 3D printing and looking at the ways in which we could use 3D printing technology to create sculpture, something that will be applicable for the fine art field, which is usually the most rarefied and exquisite kind of materials and processes. But we never saw much digital art moving into that space. So I kind of was exploring that. And through that, I created a practice where I've been creating sculptures, reliefs, things in virtual reality, which I've been producing as sculptures for exhibitions, from which I've had in galleries, I've had in art fairs, I've had in museum shows at this point. So yeah, so that's briefly been my journey till now. I'll hand it over to Vedant to introduce himself.
So, hi guys, I'm Vedant Singhania. I'm the owner of a company called Wrap 3D. And so our journey also started amidst COVID. And that was one particular time where I think a lot of people were rediscovering themselves. Our journey started with actually 3D printing itself in the realm of medical equipments and medical aid. So during COVID, hospitals had really run out of the respiratory valves. That was really a lot in demand. So there were a few hobbyists and people who started 3D printing work that time. They started mass producing these small components and producing it to the hospitals. That's where our journey started from. But once COVID got over, then we shifted our focus into more of interior design, architecture, and a lot of sculptures and art pieces. That's where I crossed my path with Virat, and we started collaborating from then on. And yes, we have been doing a lot of like small scale, large scale work, and that's what we are going to be covering in this session.
Well, so we would like to start with the aspect of 3D modeling with some examples, like in order to go the initial stages of this process after conceptualization is developing a 3D object, usually as an OBJ or STL file, which you can see as a 3D object in your computer for a specific application, ranging from simple mechanical parts to medical equipment to artwork to fashion accessories to things that you can even put on clothes nowadays, which we'd love to show you a little bit ahead. But let's start with some examples. I'll start off with some of the work that we've been doing. I'll just share some images. Yeah. So here are some examples. Here are some examples of the artwork that I've been creating using MSLA processes, which I will get to later. To just give you an overview of the kind of fidelity, the kind of finish, the kind of objects that I've been kind of creating, which is one aspect of this is like the more aesthetic aspect of this technology. Vedant and I both have kind of I've worked through so many different projects, so many different people, so many different requirements. You could call this the most highly detailed, the most kind of rarefied of and probably the most expensive of the processes. So to start off, we would like to talk about the different types of modeling which we could use, which can be like a practical guide to anyone who's trying to get into this. So that like you might be wanting to make accessories, you might be wanting to make artwork, you might be wanting to do something with fabric, whatever that might be. You will have to use a certain type of software to create that object or to create that part or whatever. So to start off, I believe very much in open source, in community-driven software and projects, and and community-driven kind of things, which are often free. So it's not linked to any big company or anything. So my go-to option is Blender. This is something that has been made by a bunch of programmers who love 3D modeling, and it's free and it's constantly developing. And I think in my belief, it's going to be the biggest thing eventually. Even they've already had like Oscar winning movies made on this software. Another option is this one called Tinkercad. You want to talk about it?
Yeah. So like Virag was talking about more of a complex type of designing. Tinkercad is something that even the basics of basic people can use. Even people without any kind of a 3D background or a 3D knowledge, they don't need to have a particular 3D knowledge about using Tinkercad. It's a very basic software. It's as simple as you just go on Google Chrome and you type tinkercad.com, and it's an online software where you can manipulate shapes in different kinds of ways. So that is one of the most basic techniques of creating very basic, like, geometrically non-challenging models. So one small example I would want to show, something that was designed on Tinkercad. It's a very basic thing. They are like some nameplates. Okay. So these, as you can see, these are really basic stuff which do not need any kind of a detailed 3D modeling in it. Similarly, we have a small miniature of a Konark temple. So even this was designed and completely made on Tinkercad. So that is one basic software. Other than that, if you wish to proceed more further into like a little bit more of detailing, then there are softwares that we can use like Fusion 360. There is SolidWorks for mechanical designing. There is
Here
Maya.
are some examples. So this is the kind of thing you could do from a parametric design software like Fusion 360. So
Right.
Tinkercad, you can open in your window right now and use it. So that barrier to entry has reduced
Sorry,
substantially. So anyone, sorry,
sorry to interrupt.
yeah,
This is a request to the organizers. If the screen of the speakers can be in the focused view, so that whatever they are showing, we can have a closure view. The
sure,
screen
sure,
is
like this.
coming as if. No, not to you. I think the organizers can do it. Make your view, your window view as the focused view.
I see.
Okay.
Thank you.
Is it okay now?
No, sir, it's still the same.
Yes, I think now it's on focus. Sir, please go ahead. I think it's focused.
Okay, go ahead. Okay.
Yes.
Yeah. So if you look at certain things like this, there's a little more. It takes a little more skill. These are a little more complicated software. But over time, they're not impossible. So these are things that we've just figured out ourselves by doing online tutorials or going on forums and things like that, or other communities. Sometimes Facebook groups is also fantastic. So yeah, here's another
Yeah, so
example.
when we talk about basic 3D modeling, we are more concerned about the generic stuff that is around us, that you see all around us. Like we work with a company called Oriplast, which basically makes these water tankers. Now this was completely designed and modeled on a 3D modeling software called SolidWorks. SolidWorks is a kind of a software that uses more of a CAD process. So we need to make a line drawing. Like for example, for this, we had to make a line drawing or a 2D version of this, and then it was extruded into this kind of a circular object to mimic the actual water tank that Oriplast provides. Now, similarly, when you go for this is more of mechanical designing. So similarly, more when you go for more of sculpting design, we use softwares like Blender and also Fusion 360 as a matter of fact, where we can go in more of human modeling and human detailing. So these are sculptures with a lot of high detail in it. You can see the textures of the clothes. You can see the textures of the pants and the folds and everything. So these are more complex models and more complex designs that we can go for. If you wish to go for even complex designs on this, then we have models like this, where we even get the textures of suppose a bird or the ground or a metallic texture or whatever.
So this would probably be made on a software called ZBrush, which is again, it is the industry standard for the best 3D modeling, but very difficult to get used to. Now with all the tools that are coming in, there are lots. It's getting a lot easier and less daunting to get started on such things. And so these are certain levels of detail which you will be using on PLA or these filament printers, which we'll get into. Uh, but the kind of images which I can show you, the kind of works that I do for the fine art scene demands a lot of detail. So then there's a different system called voxel sculpting. So when you do 3D modeling, it's a bunch of polygons. It's a bunch of triangles which form a mesh. and which can be manipulated in certain ways, not that easily. These new technologies is almost like you are sculpting in clay. So in order to you can get really fast results, really impressive detail. You can feel it a lot more. It's a less of a mechanical process and more of an intuitive artistic thing. And the best way to use certain tools is in VR. So you put on the VR goggles, and with the sensors in your hands, you can literally sculpt with your hands, and it creates an absolutely different workflow. Which I can show you an example of the VR, what I'm doing in VR overlaid on where I'm sitting. So it's kind of like it's called mixed reality. So here's an example of are we sharing? One second. And here's just a moment. Here we go. So what I've done, this is what I would see when I'm inside the VR headset. I've just overlaid it on where I was sitting. So you can see I can really get into the detail. I can select, I have all these different tools which I've created. So like I can turn a person into a brush, for example, and that's like a full 3D model which I can just place anywhere.
And the best part about this is you can make really complex designs like this within a matter of few hours,
That's
which would typically take maybe days or months.
Yeah, as you may know, 3D modeling is a very high paid, very labor intensive job. You can see it with all the movies and stuff that are made. These kinds of things make the process a lot quicker and a lot more efficient. But these are relatively new tools. And a lot of what we're talking about here are all quite new technologies, which are a bit rough around the edges sometimes, but somebody's got to do it. And please
I mean,
try it out.
as we go ahead with using these softwares, you
Yes,
slow
sir.
and steadily brush up your skills, and you exactly know how to get past all those jaggedy edges of the tools.
Yeah, yeah. Here's another example where, yeah, you can see I've got these big menus with all the hundreds of objects that I've ever created. I can just plug them in wherever I want and make these very, very intricate, intense models, which usually go for a new technology called MSLA printing, which is what I call resin printing. It's called mass stereolithography. It stands for that, which we will get into
In a bit.
in a bit. And the last thing that we'd like to excuse me. The last thing we'd like to touch on when it comes to production is the advent of the new AI tools that have been pretty exploding recently. So now we're at a point where this is what the way you do it with ChatGPT and things like that. You can literally just put an image in, or you can put a prompt in, and it will generate a 3D model.
An image, a video, or
That's right.
anything under the roof, you can just feed that in, and the AI can generate a basic model for you.
Yeah, yeah, and these tools are getting better and better. Like every month, we try it, and we get like a higher polygon, better things, stuff that we could be used practically for sculpture, fashion, this, that, anything, right? So we highly recommend using these tools. Like if you go to this place called Maker Lab, there's just a tool where you put in an image and it'll give you a 3D model. Anyone can do it. Open source, free, and yeah, okay. And then now we would like to talk about production, like these process, like these machines that we use to fabricate these things and make these products. But before that, Vedant, please show us this
Yeah.
amazing print.
So this is 3D printing done on fabric for one of the topmost designers in India, Anamika Khanna. Now,
So you can get
is that
closer.
visible?
Yeah. So this is a full color printing using a very advanced machine and very advanced processes, out of reach of most people. But you can see the results. These are like full color printing directly on fabric.
Sir, just a second for interruption. You
Yeah.
are in the share mode, so it's like the small window is visible.
Oh, I see. I see. Okay, sorry. So let me show you again. Can you see?
Yes, sir.
Yeah, yeah. As you can see, it's full color printing directly on fabric. So this is what you call polyjet, if I'm not
Right.
mistaken.
This is
Very,
polyjet.
very rare to have these machines, but it's a newish technology.
Polyjet, or for layman perspective, you can call it DTP or a DTF, direct to fabric printing. Now with these machines, you are able to print on any kind of a fabric, be it mesh, be it denim, be it cotton, silk, whatever. It's just the design that we need to make on the software that we just spoke about, and then feed it to the machine, and the machine does the rest of the job.
Yes. So, uh, next we would like to get step by step. I know this is a lots of different processes, like how are these even made? So we'll go over the kind of processes. There's FDM, MSLA, and other technologies, which are the main things that are used to actually fabricate these things. So we're going to talk about that aspect for a
I think to
second.
make it easier for everybody, we'll touch on only about 3 to 4 processes.
Yeah.
Otherwise, see, 3D printing is a very vast subject, and there are about 8 to 9 different methods of 3D printing. That means there are 8 to 9 different types of machines that do different types of work. So what we are going to be concerned about is FDM. FDM is basically called fused deposition material, which basically stands for layer by layer addition of a particular material. In this case, it's polymer, and that's creating a 3D object. So whatever you see behind you, like this, the Burj Khalifa model, the Eiffel Tower model, everything has been done using the FDM method, which is the fused deposition method. Even this one. So you could see this is a bit of a perspective art, you could say. Now, when it comes to printing, obviously there will be a question about the size. Sizes are never a foundation when it comes to FDM 3D printing, because nowadays with the open source
Let's
platform,
go to picture.
Yeah.
Yeah. I'll share. Let's
with
get
the
it.
open source platforms, there's a lot of work going on in this particular field, and the machines are developing every day. Every single day, we are getting to get something to know something new about these machines and what they can do. Just show you the small
Let's
things
start
that
with these. Yeah.
Yeah.
Okay, here are some examples of Vedang's work. Uh, up, up,
Yeah.
or down, down.
Yeah.
Yeah.
So we recently did this project where we made an architectural model of a Gurukul, which is coming up in Kolkata. And this was unveiled by Mr. Rajnath Singh in Delhi. Now, this model, typically, traditionally, if somebody goes to make these kind of models, they have to make it with sunboard or plyboard or the different kinds of methods that are there traditionally. And typically, this kind of a model will take approximately maybe a month, close to a month to finish. But we did this entire thing starting from the design to the 3D printing part to the assembly and everything within 8 days from the start of the project, and 8 days it was completed. So this can only and only be possible if you take the help of the modern tools that we just mentioned about and manufacturing tools like 3D printing. Now, even this one was something like that. There's something a process that I would like to show over here. Like if you see on the right hand side, top side of the screen, that is the basic layout that we are provided. That is usually made on a CAD software and a reference image of the original place. Then we create a 3D model of what you see on the right hand side corner of your screen. From that 3D model, we feed it to the 3D printers, in this case, the FDM printers, and then we create the final model that you see in front on the left hand side of your screen. Similarly, this kind of models are used in Bollywood. Now, this must be a very familiar model to a lot of Bollywood fans. So I'm sure you guys must have heard about a recent movie by Ajay Devgn called Runway 34. I think it's been 2-3 years for that movie to come out. Now, the entire movie was shot on this particular model. None of the movie scenes that you see was on a real life location. And the components that you see are all 3D printed. And it's a mix of FDM and MSLA, which Virag is going to talk about in a bit. Similarly, this was a model for an army cantonment area in Kolkata, Alipur. Now, these sets are also used for ad shoots for Ultratech cement. You can see we can go into a lot of detailing, which is called hyper realistic detailing in these kind of models, which give you a realistic view. This is an upcoming building, which is going to be soon there in Kolkata. We had the opportunity to make this 3D model of it. Now, again, what you see over here is a blend of FDM and SLS. The base of the model that you see in a parametric form, that is completely FDM. And all the white flats that you see on the towering building, that's completely done in SLS. This was a model done for Vodafone, where we tried to, showcase the logistic process of India. Now, where again there's a blend of FDM and SLA. The small human models that you see beside the ship ports, they are all SLA. And why do we go for SLA and why and when we do go for FDM? It's something that we can't touch later on. Go ahead. Yeah. There are a lot of engineering prototyping work that can be done. Now, prototyping is something which is very, very essential to 3D printing because back in the day, prototyping was a process that took a lot of time and a lot of money. Nowadays, with the advent of these, softwares and these tools, we can design a prototype within a matter of few days, and the prints can be done within a matter of few hours. So your entire product turnaround time is lesser than 50% than what it used to be.
Right. And all these other tools, like for example, 3D scanners are getting so much better. All these your phone can do. You can take a bunch of pictures from your phone and create a model out of it. So even if you wanted to make custom, say jewelry or something customized to someone's body, these processes are a lot quicker.
Like on the right hand side of your screen, you see a triangle shaped device. So that is basically a company that is trying to replicate fishing rods, which you get in America, and they want to replicate the same thing over here. Now, typically, because of a lot of copyright processes and copyright issues, we will not be able to get the actual thing. But we can always remodel and re-engineer by looking at the original photograph by making our own changes. These are some, again, models done for interior design. Now, these are large scale FDM 3D prints where typically what you just saw right now are, say, probably the size of, say, 1 feet or 1.5 feet. But these models that you see, they are made by machines which can print up till 10 feet. So you can make out and out furnitures, you can make out and out vertical garden solutions with this, like the one that you see right in the middle. It's a stackable option where you can stack up these vases as high as you want to go. And irrigation system and everything can be taken care of within this. On the right hand side, the parametric chair, the red chair that you see, it might look like it's really weak, but it can take weights up till 200 kilos. And it is all in all because of the shape that we provide and the kind of a center of gravity that the chair provides. And everything is achieved in the designing part, in the softwares. Here are some audio structures. What done by
and in fact, let's just close up the FDM thing. We'll also see what were we'll briefly go over how this FDM process works. As you can see, there are like these lines on on all of these objects, right? The reason is you put the filament through the material through an extruder, which heats it up and builds it up layer by layer, right? So similarly, so this is all. So these are you're using certain types of spools, be it PLA, whatever. Similarly, there are machines where you can inject clay into the machine and it pushes it through a tube and builds it up layer by layer. So like that, we can actually do ceramic printing, which is if we scale that up, then that's how we print buildings, which we'll also touch on. But it's a very similar technology where you're like putting something in, pushing it through, and then the machine builds it up. And like the XY data is fed into the machine and it knows where to go and where to deposit. So
See, essentially the process FDM is the same. It's just the material that keeps changing. Like for FDM, we can use polymer, we can use clay, we can use concrete, which we're going to touch in a bit. For clay, we can show a small video.
Yeah, this is on one of my machines. 1 second, let's get the sharing. Yeah. So as you can see here, it's a very similar setup to a FDM thing, except that you have a syringe with clay on the other end, and that is depositing this clay very precisely. And it builds it up layer by layer. And then after which you take it off the printer and you put it through whatever processes you would normally put ceramics through, which is glazing and baking. You bake it once, you bake it twice. And this can also apply to jewelry. So this has been done. So this is an example of the kind of intricate detail you can get by using these technologies.
Now, typically, these kind of sculptures will not be, possible to be made by hand. Or even if somebody could, it will take him or her days or probably months to do it. But there's a matter of few hours.
Yeah. And here's an example. Like I've just lit one of my sculptures from the back, so you can get here. And here we can show you the exact thing. As you can see, in fact, we have one right here, and you can even, if you can tell, even little people climbing all around it, like right on top, you will see. So in order to get detail like this, you don't see any layer lines, right? Like as you see in the other ones. That's because there's a different process for this called mass stereolithography. Interestingly, it was actually the first form of 3D printing that was invented, but it's very toxic. It's using resin and it's very expensive. Like you need a special type of resin. So you can imagine, imagine an MRI scan. So you're basically putting slices of an MRI scan into the printer and it builds it up with inside of a resin wax. So it's all happening kind of underwater. And the layers kind of are very, very delicate. And this platform goes up and down and builds the layer up little by little. I can show you an example of what these machines look like when you're like getting them out or operating them. This is after print is done. This is what I have to do. I have to like get this off. You can see it's built up layer by layer. It's in this white vat of white resin. You have to kind of take this off and then put it through a process of post-processing. You have to scrape it off, get off the supports. Then you have to clean it out to get all the resin off. And then you have to UV light it to harden it further. It's a
tedious process.
It's a tedious process and very labor intensive. So people who give you the impression that 3D printing is all automatic, it's not. There's a lot of as the technology gets better, hopefully there'll be less of this for us to do.
Right.
But right now, at this stage where this is a requirement, and as you can see, it can get quite messy, but that's part of it. But you get the most beautiful, stunning details. So yeah.
Now, just a quick overview about why and when FDM and why and when.
Excuse me. May
Yeah.
I just interrupt?
Yeah.
The screen share is not being observed by any of the viewers over here.
Okay. Let me try again. This was the video I was just playing. Can you see it now? Is it visible?
Yes, sir. Yes, sir.
Okay, great. So this is what the video we were just showing as part of one of the post-processing steps when doing resin printing, just to show that it is quite a daunting and complicated task, even though all the printing is doing all the heavy lifting. There are many stages for certain results, certain technologies, right? So for PLA, you won't have it'll be a different support system, a different post-processing, barely any post-processing in comparison to something like resin. But what's very interesting about resin is you are able to print in wax nowadays. It's a highly expensive material, but you can print in wax and then go through the process called lost wax casting. If you've heard, it's one of the oldest. In fact, I think it was invented somewhere here. It's where you take an object in wax, you cover it with some ceramic protective coating, like layers, and then you melt the wax out, and then you pour metal in, and then you get a metal object. So one of the most, I'd say, rising and popular ways of doing metallic jewelry, like really, really beautiful fine stuff, is using this process where you print it in using these printers in a mixture of resin and wax material, and then you go through the lost wax process. And that has been, and the kind of geometries you get with that are far more intense and intricate than anything you can do by hand, by any other process. Yeah, sure.
Yeah, we can.
Do the screen share first. Yeah. So we can show you some examples of the kind of 3D models that can be turned into jewelry, be it in PLA, resin, metal. And this type of modeling also has its own process and its own kind of level of intricacy, which is quite unique. So it's its own aesthetic, which is kind of developing.
Now, typically, these kind of jewelry is going to be really difficult to create by hand. But as we go with the process of MSLA printing and the lost wax casting method, these kind of jewelry is very easy to achieve.
Yes. For the yeah. So and one thing to keep in mind, this is again the advantage of this is the rapid prototyping aspect of it.
Absolutely.
So say you're making 1,000 of these, you might not want to be using this process, but if you need 5, this is exactly what you need, and it's way more cost effective than any other industrial other process. As you can see, the kind of geometries you're getting here, you will not get using other processes because they're just simply too intricate.
Absolutely.
You want to briefly touch on your buildings?
Yes.
Yeah.
So
We'll wrap up the
before I
process,
touch
yeah.
on the building part, I
Yeah.
just want to just quickly tell you when and why FDM and when and why SLA. So as
So no more screen sharing, unfortunately, since we're on the phone. But we'll kind of just wrap it up with a few
Yes.
what we were as we will continue.
Okay,
So
please go ahead.
the last thing we would like to touch on is so we've gone over the modeling, we've gone over the machines and the processes. Now the last thing is how do we get this to market? Like how do we create the final products that can be either displayed in a gallery or to be used in a shop or to be used on a runway, uh, which we should also discuss. So for that, it's the process of post processing. So for my resin sculptures, for example, I had one issue where they were a bit fragile. They weren't as strong, and they were a bit of an unknown material. So we weren't many people don't know what resin sculptures are like. So I started experimenting with this process called electroforming, which is slightly different. It is like electroplating, but slightly different, where you actually create a metallic surface on top of something that's non-metallic. Electroplating is something when you put a metal on a metal. This is a way more difficult, a far more difficult process, which involves creating conductivity through graphite and things like that. So once I started practicing that and working on my process, I was able to put a layer of metal on top of any PLA resin, any sculpture. So that put it, and then I started patinating it to make it look like it was old, right? So that created the kind of look and the finishing that was required, which was approved by the, you could say, the art galleries and the people wanted to buy them, and it finished at mark. So that is one very essential aspect of using these technologies is the post processing, the finishing, and often you want to add something more. Like just PLA sometimes is not the perfect thing. You need to add things to it to spruce it up, to give it strength, to give it aesthetics, whatever that might be. So yeah.
like for example, we did this piece. This was done in two parts. This part was printed separately and the hands were printed separately. And then we had to join it. Now, joining is also a very crucial part when it comes to 3D printing because a lot of times we need to make really large sculptures, but our machines are not large enough to make it. Now, there might be a question where you can say that, yeah, we can have large machines. But when you have large machines, you have a larger and a wider area of failure. So what we try to do is we try to break up the model into various number of pieces. And then in the post-processing part, we either we glue it or we weld it, or we have a male-female joint that we use to make an entire model standing. Now, when it comes to FDM post-processing, it's quite similar to SLA as well, but a little bit more tedious, what I would say, because when FDM, there are a lot of layer lines, as you must have seen. Now, there are different designs. There are some designs which might require the layer line to be present. In that case, there is no post-processing involved. But when somebody is like, no, I want a smooth finish, then we need to go for the sanding and buffing process. Like, for example, I'll show you this. So this was a sculpture clay head that was made. Now this, you will not be able to see much layer lines on this because this has been post-processed and this has been sanded to give it a smooth finish. Once the sanding process is finished, we go for the priming or the painting process. Now painting process is something that Virag is going to give you more light about.
Yeah. So when it comes to painting, one of the great advantages of so say if you were to paint something that's like a very intricate house or something, the easiest way for you to do it would be if you had a bunch of flat surfaces you could work on and then put it together. What's interesting about these processes is you can, say for example, cut a house up into little pieces and airbrush each part individually with masking tape and things like that. So you actually can get very good finishes. Otherwise, once you try to take a brush and go in there, it can often create a mess. And here's another example of post processing where here we have a print of a clock. And I guess the post part would be him just attaching a clock, as you can see. So it's customized for whatever preset clock that he had. And we got a pretty beautiful little object, I think. So this is also, so when using this technology, it's always using it with something else. And that's one aspect that we have learned over our years of experimentation. Yeah.
Yeah. Cool. Now, I would just
Rapid.
quickly take a moment to show you what are the other things that are possible with 3D printing. Like we were talking about the building aspect and the large scale 3D printing aspect of it. So just give me a moment. I'll try to share my screen on my phone itself. Yeah. Okay. Is the screen visible? Share photo. Yeah. Yeah. So you just share this. Then your photos. Yeah. It's okay. You can, I guess you can just talk about it. Yeah.
So, Mr. Desai, I think you can just speak because it's taking time. Mr. Desai, can you hear me? Hello. Hello. Yeah, we cannot hear you. We cannot hear you. The sound is not there. We cannot hear you. We can see you. We cannot hear you.
Yeah, are we audible? Hello?
Yeah, yeah. Okay.
Great.
Yes, sir.
Yeah, sorry about that.
Yeah,
Yeah. So,
unfortunately, we are having some problem with the screen sharing. So would be unable to share any other content, but we are happy to take any more questions.
okay. Thank you. Thank you for that wonderful session. It's new for us. And we know that there are some technical problems. So, over to the participants. So, I think uh, someone has raised the hand. Please go ahead, unmute yourself and ask your question.
Hi, Vedant. This is Dr. Grishma. So I'm also teaching School of Design, and it's all about immersive media tech. And what I was fascinated about that the way you were creating sculpting through VR headset. So I would like to know what kind of application you were using, because I have this Meta Quest 3.
Yes.
And if you have any recommendation for that, like what kind of 3D models or art related any applications which I can show to student.
Yes.
So
Yes, exactly. So, in natively on the headset itself, there are some sculpting tools. There's one with from Google, if I'm not mistaken, which are quite simple.
okay.
I'm using, you have to hook it up to your computer. So you wire it up to your computer, and then it's a free software. It's called Adobe
Mm.
Medium. It's a VR software, so you connect it to your computer and you run it from the computer, and that's where it can handle heavier loads. So
Okay.
it's
Its
called
name
Adobe Medium.
Adobe Medium.
Medium. Yes, that's right.
Oh, that's
That's a
great. That's
what you call a voxel VR sculpting tool. Yeah,
could you spell it?
yeah, it's called Medium.
Oh,
Medium. And the
okay.
type of tool it's called voxel. Yeah. It's a type of
Voxel.
technology it is. So that's slightly different from the other tools.
Okay. Okay. That
Yeah.
that was great. So yeah, the question was related to the sculpting or the 3D printer, using that 3D printer you were showing, sir. And some AutoCAD model you suggested, like a Tinkercad.
That's right.
So
That's right.
will it be advisable to use this Tinkercad to teach the ergonomics, principle of ergonomics to science?
Absolutely. In fact, it's the best software to use because it's very user friendly. You can just open up a
Okay.
tab on your browser and it use it
Mm.
from there only for free. So it's quite
Okay.
easy and accessible. So I highly recommend if any you want to be even teach a child 3D, you start with Tinkercad. Anyone. It's a perfect
Okay.
starting. Yeah. And
Okay.
then later on you can do more advanced stuff like Blender and all.
Okay. That would be great. Thank you so much. Thank you.
Yeah. Most welcome.
Yeah, any more questions?
Good, sir. Video on good.
I'm sure it's
Hello, Vedam. Am I audible and visible?
Yeah. Hi.
Amazing session, and the seeing your age and everything, it feels so low that we are left behind a lot, being into 22 years into this field, but it feels that I'm zero. Thank you for this enlightening session. Now, since I am a fashion academician, suppose if I want to establish a lab for the DTF, direct to fabric, uh, what would be the basic setup and what would it cost? Because I need to give the cost to the company, to my college, and
Right.
I need a basic setup view on the same.
Any kind of a basic setup for, especially when it comes to fashion 3D printing. The first and foremost thing to do is invest in a very, very good designing software, because when we are dealing with the machines that we are talking about, they can print really intricate details, right? So first and foremost, it's a necessary thing to do is invest in a good designing software, specifically a sculpting software and not a mechanical software.
What
Secondly,
would that be? Can you name some, suppose our designing software if I propose? So what initially you can
you can
just
go for
take up that
ZBrush.
it should be
You can
basic.
you can go for ZBrush. ZBrush is a very good option. Now, if you want to create geometric shapes on fabric, that in that case you can go for either SolidWorks or Fusion 360, and also Blender
SolidWorks, SolidWorks or Fusion 360.
That's right.
360. Now, if you want to go for a more open source software, Virag was talking about Blender. Blender is something that you can also experiment with, but since it is an open source software, it is continuously developing and continuously evolving. So I would rather suggest that you could go for the ones which are traditionally present, and then once you set your hand in that, we can go for Blender. Now coming to the machinery part. See, the basic machinery is offered by a company called Stratasys. They are an Israeli company, and the fabric, the DTF printer starts from about 5 CR, if yeah, about 5 to 6 CR. That's just the basic machine. Now there are three versions of that machine where you can print different sizes of fabric. Now the one that I'm talking about, the basic one, you can print only a fabric of this size, which I hope this is visible.
Yeah, that is what you had shown during your lecture also.
Earlier,
Yeah,
yeah.
correct. This
In
is,
fact, there's another one.
yeah. The other one that I'm going to be showing you, it's more of geometric patterns.
What is the colors which you take and the what's the pigment
We
or
do not,
what you use in that
we do not
machine?
have to take anything. The machine is capable of printing more than 16 million color gambits. So
And
all
is it like something? See, I've seen the details. I've seen the detail, but your whatever you were showing appears to be a little different. Maybe it's on the screen.
that's
But
the
is
what
it
the
is it embossed? Is it on the layer a little what do you call a puffy one or something like that?
Yes, correct. So exactly what I was coming to, the DTF machines that you have seen, they print only on X and Y axis, which is on a flat bed. But the machines that I'm talking about, they print on X and Y and Z axis as well. So there is a little bit of a bump, or you could say a little bit of an embossment in the material and in the designs. So that embossment can also, you can set that embossment in the software or the designing software itself. Where suppose you want, like say suppose you are making a garment for the fashion industry or a runway or something like that. So you want to have maybe spikes coming out of the shoulder. The spikes can be of different height. Now, all those height you can reset in the software and just feed it to the machine, and the rest of the job will be done by the machine.
Oh, so you
But
mean
these
to
are
say
some
that? So sorry. Please continue.
No, and one thing to keep in mind, unfortunately, this technology that we're talking about is the most expensive
Absolutely.
of them all.
Absolutely.
Yeah.
Oh, so this would cost?
Like I tell you,
Crores just to get the machine, like
yes.
4 5.
No,
Just
no.
the machine.
Sorry. Come up again. Sorry.
4 to 5, apparently 4 to 5 CR just for the machine.
No,
For
the
this
initially you said the basic machine also cost 5 CR.
Yes, the basic machine is 5 CR, starting from
for
that.
this one. And in fact, the machines that we're using here are like 25,000 per machine. Some of them, the cheaper ones. So
I
it's
want to know
really-
about these. I want to know about these machines also. Just don't jump to the
Yes, there are
exactly to
various
the 5 CR,
methods. There are various
25,000
methods.
ones also.
See, there are various methods of printing on fabric. Like I told you, like we showed you this method. This is the most expensive of them all. But
Yeah.
you can print on fabric with our basic FDM machines also, the ones that print polymer.
Yes.
But that itself is a technique altogether. So
Yeah.
we are a little short on time to explain you the technique of how you can print on fabric with that machine.
But can be done.
But
As
it
well.
can
So you
be
don't
done.
have
But
to
it
get the
can be done.
expensive one.
I just
Can be-
want to understand that I want to start a basic setup. So for
Yes.
that basic setup, students they just come from the 12th standard and just to show them and have more interest of them towards more textile and fabrics and the innovative technologies and AI generated things. And
Yeah.
we cannot avoid, like we could not avoid internet, we could not avoid calculator, we cannot avoid AI also. So
Right.
I want to integrate it in my teaching. Hence, I asked. So the cheaper machines do come of 25,000.
Yes,
Yes,
they do. They do.
25,000, 50,000,
Yeah.
75,000. There are
And
different ranges. of what you
Say,
can
say
do.
there's one machine called the Bamboo Lab A1 Mini for under
Please,
25,000.
can you please repeat that? The bamboo
Bamboo Lab. LAB.
LAB
Yeah. A1 Mini. A1 Mini. Okay.
A1.
This
Okay, fine.
machine is for 22,000 and it prints almost automatically. So it's very easy to use and perfect for teaching people and people who don't know any of this stuff. It's the best way to learn. And it's often the machine I use mostly. because
And
it's
do
so
you
efficient.
travel to away from places like Lucknow and other to teach these students?
Yes, yes, definitely we do.
Okay, thank you. Thank you. That's
Thank you.
over with me. Thanks a lot for all the answers.
Thank you.
I guess there is another question. If you just can unmute and go forward.
Yeah.
Mr. Rajvinder Kaur, I guess you have a question.
Well, okay, the session is really insightful and very educated. And I think there is no more question from the participants, so we can end up today's session. Thank you, sir, for joining us and enlightened us with so much information about software, technologies, art, and everything. Thank you, sir. Have a
Thank
nice
you
day.
so much. Thank you. Thank you.
Thank you.
Okay, so thanks to both of you. I think uh, like Virag, your names are so similar. Sometimes I get Virag and Vedang
Virag and
because
Vedant.
Vedang, yeah, Virag and Vedang.
Vedant,
Virag and
sorry.
Vedang. So, like we have been going through the past 3 days, the rest of the sessions, which were nice, but your session was totally out of the. We were expecting it to be out of the box, and it has been so. So it will definitely, we are not from that particular stream in which you are working. So it gave us an idea. So that is the purpose of an FDP, that, these are the things which are also possible. Okay, so we will take it forward. So thank you for coming and thank you for giving time. Thank you for making the preparation, all those things. So we look forward to more such, connecting and this type of interactive sessions with you, maybe perhaps when the students come in our college in Amity University. Thank you.
For sure.
Sure.
Thank you so much, sir. We
Thank
would
you.
Thank
love
you.
to
Bye.
get a session with everybody.
Excellent. Thank you so much.
Thank you, dear participants. We'll see you tomorrow also with our next two session, and that would be the last two session. And please do participate at the last day. We have our assessment and feedback that you need to fill up after the session got end. Uh, Thank you all. See you all tomorrow.